Okay, physics fans, welcome back, and we're going to continue on with this chapter 3.3 example of momentum in 2 dimensions for physics 12. A 2 kilogram bowling ball traveling at 5 meters per second collides with a stationary 0.3 kilogram bowling pin. If you don't have this is on the handout. You can just go grab it, just above the link on Moodle. After the collision, the pin moves at a speed of 6.5 meters per second in a direction shown in the diagram at 37 degrees if you want north of east. What is the velocity, which is magnitude and direction of the bowling ball after the collision? So this is a collision, boom, conservation of momentum. Let's work on it. So it's coming in at 5, mass is there. So the momentum in the x direction beforehand. So this guy has a velocity and a mass. Its momentum of the ball is mv, which is going to be 10 kilograms meters per second east. Here's the pin, and its velocity is 0, so its momentum is 0. So let's find the momentum before in the x direction. Well, the momentum in the x direction is the momentum of the ball in the x, plus the momentum of the pin in the x, and that is just going to be 10. And since nothing is moving in the y, the momentum before in the y direction is 0. Therefore, the total momentum of the system, the whole system, is 10 kilograms meters per second east. If there was some y, then we'd have to do it x and y and get the total as a vector. Okay, let's scroll down a tiny bit. Find the momentum of the pin afterwards. So, the pin's mass is 0.3. So let's pull up Mr. Calculator, even though I could do this in my head. Greetings to you. 0.3 times 6.5. Oops. 0.3 times 6.5 is 1.95. So its momentum is 1.95 kilograms meters per second at 37 degrees north of east. Now it's saying, what is its momentum in the x direction? So momentum of the pin, and that's afterwards, is going to be 1.95 kilograms meters per second. We just did it up there, times the cosine of 37, because we want the adjacent component, not the vertical. Down here we want the vertical. And then therefore the pin in the y, this is the x, is going to be 1.95 kilograms meters per second times the sine of 37. So let's pull up the calculator, multiplied by the sine of 37, and take that number and times it by the cosine of 37. Okay, and these are the numbers. The x is 1.557 kilograms meters per second east, and this is going to be 1.179 4, if we want, round that up, 4 kilograms meters per second north, because the pin is heading northward. So that's its momentum in its components. Okay? Now use conservation of momentum in the x direction to determine the momentum of the ball afterwards. Now remember, what we're working on is from the notes yesterday, is that we get the momentums in the x and y, and that's what I just did. The momentum of the pin in the x and the y afterwards. And we know the momentums in the x and the y beforehand. Okay, and now we're going to use this stuff to conservation in the x, conservation in the y to find the ball's momentum. So using conservation, the total momentum in the x beforehand was 10. And the momentum of the ball afterwards is what we're going to try to find. And the pin's x is 1.557. So this is pretty easy math, right? You can see this. 10 equals that plus that. That's why I'm trying to make it really simple here. So this is just going to be P, the ball in the x, is going to equal 10 minus 1.557. Okay, and let's see if we can do that by, this is going to be what, 443 east, and in the y, here's the y, the total beforehand was 0. So the ball, Py of the ball, and this is going to be 1.174 kilograms meters per second north. This was east, and this was east. North, but they both have to add up to 0, so this gives us the P ball in the y, sorry, just changing the order, ball y, ball, y is going to be 1.174 kilograms meters per second south. Now, the whole idea was to get the momentum, the velocity of the bowling ball afterwards. Well, we have its components of its momentum. So we're going to combine the momentums to get the total momentum and then just divide it by its mass. So this is going to be 8.443 and 1.174. Pythagoreously join them, get the angle, and then get that magnitude there and divide by the mass. It's not too hard here, I don't think. So we'll take 10 minus that number to get the 8.442. I said 3. Oh yeah, 26. Gotcha. And then we square that, and then square that Pythagoreously, so I square root it. That number squared plus that number squared. So the hypotenuse, so this is the momentum vector of the ball, is 8.524 kilograms meters per second. And if I need to write down my work, it'd be 8.443 squared plus 1.174 squared, all square rooted. And then I have to do the inverse tan. The inverse tan of opposite 1.174 174 over the hypotenuse, over the adjacent, so 0.443. So inverse tan, we've done this probably 100 times in the class already. Theta is equal to 7.916 degrees. So the momentum, we'll put it right here, is 7.916 degrees south of east. That's the momentum. Now convert the momentum to the velocity. We just take that velocity is going to be the momentum vector divided by its mass, P equals mv. So we take this number and divide it by the mass of the ball. What is the mass of the ball? 2 kilograms. And divide them in half. So the answer is going to be 4.262 meters per second. I got rid of the kilograms. And the direction is still going to be the same. 7.916 degrees south of east. That's the velocity of the ball afterwards. Now let's just do a quick review of what we did, just so you understand the steps, because not every question is going to be laid out like this. So the ball is traveling and hits a stationary pin. So we now know that the ball has all the momentum beforehand, the pin has none. So we find out what the total momentum of that is here. And now we know this guy's total momentum. So in theory, we can get the ball's total momentum in a moment. So it's because the sum of these two has to equal this. So we find that the ball is moving at 10 with a momentum of 10. And then we find out what the momentum of the ball is. And away we go. We break these apart, and we know that 10 has to equal this plus the other thing, the ball. So we just take the balls, X and Y, figured it out, and then combine them together. Now, another way to do this, good, I got your attention. Another way to do this is doing it vectorially, all in one. That's it. It's going to be a sine law, cosine law one. Remember that type of stuff that we learned in static equilibrium? So this is the total momentum, 10. The momentum of the pin afterwards is 1.95 at 37. And then we have to add the momentum of the ball. The pin and the ball has to equal what it was beforehand. So the sum of the afters have to equal the sum of the befores. So with this, we could use cosine law to get the length of this, but then it's tough to get the angle, because you got to get that angle and that angle there. But you could do it, sine law and cosine law. Anyhow, there we go. That's number 2. Sorry for taking so long, but I wanted to go over in great detail. Thank you. Enjoy, subscribe, like the question.